This is the Apache Kafka official documentation, which will go to it. Let's first see its sections, and we'll begin with the first ones. We have the getting started, which discusses the use cases, the quick start ecosystem, upgrading the APIs, which discusses the various APIs such as producer API, consumer API, streams API, connect API, admin API. Section 3 is the configuration, the broker configuration, topic configuration, Kafka Connect configuration, admin client. Section 4 is the design, the motivation, persistence, efficiency. It's great that they put it behind the scenes, the replication, the log compaction, the quotas, the implementation of Apache Kafka, the network layer, the messages, the message format, log distribution, the operations, the basic Kafka operations, adding and removing topic, balancing, limiting, data centers. So it looks like more like administrative operations that are there in Apache Kafka, monitoring, security, lot of good stuff here. Zookeeper, KRAF for synchronization, which topic exists, security, encryption, authentication, SSL, also good stuff here. Kafka Connect, which the connector, developer guide, APIs. Then the last section, section number 9, the Kafka streams. Play with stream application, write your own stream application. It looks like a final summary. So let's begin with the first section, which is basically the introduction. We go through it quickly. I take it that most people already know what in general is Apache Kafka, what's its usage, but so I'll try to go to the first section quickly. Getting started, introduction. What is event streaming? Event streaming is the digital equivalence of the human body central nervous system. So the analogy is the human nervous system, and we have a lot of events flowing through the nervous system, right? We have events coming to our eyes, ears, skin, everything is coming through, and we need to collect them, and something need to consume them and handle them. Okay. I don't know if it's Kafka in our body or something else, but let's hope that, yeah, okay. So, event streaming is the digital equivalent of the human body central nervous system. It is the technological foundation for the always-on world where business are increasingly software-defined and automated, and where the user of software is more software. Technically speaking, event streaming is the practice of capturing data in real time from event sources. Real time, let's see what it's going to be. Is it sub-millisecond, more than 1 millisecond, etc. Like databases, sensors, mobile devices, cloud services, and software applications in the form of streams and events. Storing these event streams durably for later retrieval, manipulating, processing, and reacting to the event streams in real time as well as retrospectively. We have both real-time handling and retrospectively for things that happened in the past. And routing the event stream to different destination technologies as needed. Event streaming thus ensures continuous flow and interpretation of data so that the right information is at the right place at the right time. Some marketing. What can I use event streaming for? Event streaming is applied to a wide variety of use cases across plethora of industries and organizations. Its main examples include, let's look at one example and skip this. To process payments and financial transactions in real time, such as stock exchanges, banks. Yeah, sure. So we process things. Here it's payments, which means it needs to be very accurate and consistent. Check out some other lectures that I have about consistency, database consistency. So payments, we want to be sure we are right. Tracking how many likes we have on a post, it's good. Also, if we missed some, I mean, it won't be the end of the world. Payment, it's also not the end of the world, but it's critical. Okay, to connect, store, and make available data produced by different divisions of the company to serve foundations for data platforms, event-driven architectures, and microservices. Yeah. So it's like the nervous system is a good analogy. Apache Kafka trademark is an event streaming platform. What does it mean? Kafka combines 3 capabilities. So you can implement your use cases for event streaming and to end with a single battle-tested solution. Battle-tested, I fully agree, because almost everyone are using Kafka. 1, to publish, which is to write, and subscribe to, which is to read, streams of events, including continuous import-export of your data from other systems. to store streams of events durably and reliably for as long as you want. 3. To process streams of events as they occur or retrospectively. So we have the read, the write, the storage, and the processing. Okay. Usually I treat it as a temporal processing. They didn't specify here that it's like a temporal processing, meaning I don't treat it as the database, but let's see. And all these functionalities provided in distributed, highly scalable, elastic, unless you call also a temporal storage database. Highly scalable, elastic, fault-tolerant, and secure manner. Kafka can be deployed in bare metal hardware, virtual machines, and containers, and on-premises. Okay. Yeah, and we have also Kafka. How does Kafka work in a nutshell? Kafka is a distributed system consisting of servers and clients. Okay, it all boils down to servers and clients that communicate via high-performance TCP network protocol. So they use TCP network protocol and they have a layer on top of it. So it's not HTTP on top of TCP. It's something, probably their own protocol on top of TCP. Yeah. It can be deployed on bare metal hardware, virtual machines, and containers on-premise as well as cloud environments. Servers. Kafka is run as a cluster of one or more servers that can span multiple data centers or cloud regions. Some of these servers form the storage layer, called brokers. This is an important point. The brokers are the storage layer, because there is a lot of talk in Kafka about the brokers. So it considers them as the storage layer. Other servers run Kafka Connect to continuously import and export data as event streams to integrate with Kafka with your existing system. So we use Kafka Connect to connect to other systems and to continuously import and export data, such as relational database as well as other Kafka clusters to let you implement mission-critical use cases. The Kafka cluster is highly scalable and fault-tolerant. If any of its servers fails, the other servers will take over their work to ensure continuous operations without any data loss. Clients. They allow you to write distributed applications and microservices that read, write, process streams of events in parallel, at scale, and in fault-tolerant. This is why I like the official documentation, because we actually see the whole meaning and the whole pictures. Blogs are also good and videos are also good, but we need to start from somewhere. At scale and in fault-tolerant manner, even in the case of network problems or machine failures, Kafka ships with some such clients included, which is augmented by dozens of clients, provided the Kafka community. We have Kafka for all the languages, Python, C++, and more languages, as well as REST APIs. Main concept and terminology. An event records the fact that something happened in the world in your business. It is also called record message in the documentation. When you read or write data to Kafka, you do this in the form of events. Conceptually, an event has a key, value, and a timestamp, and optional metadata headers. Here is an example event. Event key Alice. Event value made a payment of $200 to Bob. Event timestamp June 25, 2020 at 2:06 p.m. Producers are those client applications that publish write events to Kafka, and consumers are those that subscribe to, read, and process those events. In Kafka, producers and consumers are fully decoupled and agnostic of each other, which is a key design element to achieve the high scalability that Kafka is known for. For example, producers never need to wait for consumers. Kafka provides various guarantees, such as the ability to process events exactly once. Events are organized in a durable, stored in topics. Very simplified, a topic is similar to a folder in the file system, and the events are the files in that folder. An example topic could be payments. Topics in Kafka are always multi-producer and multi-subscriber. A topic can have 0, 1, or more producers that write events to it, as well as 0, 1, or many consumers that subscribe to these events. Events in a topic can be read as often as needed, unlike traditional messaging systems. Events are not deleted after consumption. Instead, you defined for how long Kafka should retain your events through a per topic configuration setting, after which all the events will be discarded. Kafka's performance is effectively constant with respect to data size. So storing data for a long time is perfectly fine. Topics are partitions, meaning a topic is spread over a number of buckets located in different data Kafka brokers. This is the way it scales out. This distributed placement of your data is very important for scalability because it allows client applications to both read and write the data from too many brokers, we said the ones that store the data, at the same time. When a new event is published to a topic, it is because if you have many clients and many producers, if it's really sending a high volume of traffic in and out, then you want multiple nodes. The way they do the multiple nodes is to separate a single topic into multiple nodes with partitioning. When a new event is published to a topic, it is actually appended to one of the topics partitioned. Events with the same key, and we use the key to partition. Example, a customer or vehicle ID are written to the same partition, and Kafka guarantees that any consumer of a given topic or partition will always read that partition's event exactly at the same order as they were written. So we have here a single topic, multiple partitions, and we have the producers based on the key are sending to specific partitions. Figure this example topic has 4 partitions, P1, P2, P3, P4, 2 different producers. Clients are publishing independently from each other new events to the topic by writing events over the network to the topic partition. Events with the same key denoted by their color in the figure are also written to the same partition. Note that both producers can write to the same partition if appropriate. To make your data fault tolerant and highly available, every topic can be replicated, even across geo-regions or data regions or data centers, so that there are always multiple brokers that have a copy of the data just in case things go wrong. You want to do maintenance on the brokers, or you want to do maintenance on the brokers, and so on. A common production setting is to have a replication factor of 3, i.e. there will always be 3 copies of your data. This replication is performed at the level of the topic partitions. This primer should be sufficient for an introduction. The design section of the documentation explains Kafka various concepts in full detail. Great! If you are interested. So we finished with the first section. We saw basically broker stores the data. We saw we have topics. We saw we can send events, get events. We saw that we have the key. Each event has the key and the body and timestamp, and the key is used for the partitioning of the data. And the topics can be replicated, and usually they're replicated across 3 nodes, partition factor of 3. So this was the first section, and we'll move on next episode with section 2, the APIs. Looks great so far, written clearly. Yep, I'm expecting this.